I'm not Oz Parchment, as you can see. I'm just standing in as chair unless Oz runs into the room, at which point I will let him get his breath and potentially cede my position. Unless it's going well, in which case I might carry on. This is the novel technologies session, and I'll give a quick overview after just saying you saw me yesterday up here. I run the research software group at Birmingham. I've been involved in setting up a lot of our infrastructure. We lost our HPC sysadmin when we were delivering a new HPC system, so I got the enjoyable job of becoming an HPC sysadmin, so I had some fun with that for a while. We have had a Power 9 system with V100 GPUs, so non-x86 processor. We got that. We may tell more about that later potentially. Novel technologies. As I was thinking this, I was thinking, what's the definition of novel? Well, novel to us. So we've just ordered an AMD GPU, which is novel to us. That may be not novel to lots of other people. This session is about novel technologies in our research computing environments. What we have today is in many cases built on the outcomes of experimentation, the implementation of novel technologies in the past. And new stuff is coming out all the time. Vendors bring out new things. New chip manufacturers every so often turn up. Some chip manufacturers pull out of the HPC market. How do we balance between making our existing environments stable and looking after them and evaluating the novel stuff that we may want to use? Do we leave that to other people? Do we all watch the other groups around, and when they say it's good, we take it? The whole point of what we do is to deliver value to our community in our university or our wider communities. How do we do that? Do we want to bring in novel stuff? So that's enough from me. I'm going to ask the panelists to introduce themselves. I'll go along the table first and then we'll check online. So Heather, do you want to kick off?
Okay. Hi everyone, I'm Heather Turner. I'm an EPSRC funded RSE fellow based at Warwick University in the statistics department. I think I'm here to sort of extend the scope because I'm not generally very focused on infrastructure or technology, but general RSE practices and introducing sort of new ideas to people in the different contexts. So for example, in the stats department, encouraging them to use version control and to make proper software releases, or across the university, introducing R to people who are used to point-and-click software, or introducing HPC to people who are used to working on their computer. So that's kind of the context I'm coming from.
That's interesting. It's the novel to whom again, isn't it?
Yes, exactly.
You know, what is new to a theologian? I'm a theologian in part of my life. What's new to a theologian is not the same as what's new to some other people. Mark.
Hello everyone, you all know who I am now. Mark Parsons, the director of EPCC. We operate a lot of equipment, some of it very big, some of it national services, but we've also got a lot of little systems too that we explore novel and new technologies, and I think that's a really important thing to do actually. It just often isn't public, or it's not a system that is easy to share, but I think we can discuss this a bit as we go through.
Yes. Phil?
Well, I'm Phil Hasnip. I'm an EPSRC Research Software Engineer Fellow. I'm also one of the Knowledge Exchange Coordinators for Excalibur, so we are facing some challenges related to novel systems there, both at scale and in its nature. And 20 years ago, the main code that I developed was thrown away and written again from scratch, and that might be a useful experience to share later on, depending on where the discussion goes.
Thank you. So online, I think we have Tobias. Do we have Tobias?
Yeah, you have me. So yeah, you've probably seen me before on Mondays. I'm Tobias. I'm working in Durham University in the Department of Computer Science, and I really have probably two hats on today. On the one hand, I'm probably more on the theory side of scientific computing, a researcher, and my interest is really how to bring the latest mathematical algorithms, the coolest mathematical stuff, and our hardware together. And for this, I permanently evaluate my algorithms on new systems. And on the other side, I'm also responsible for the IT provision in the Department of Computer Science. So we have a small number of smaller clusters here, one GPU cluster with A100s. We had a collaboration that unfortunately now had to terminate due to political reasons with a company who had, for example, deep memory systems with Optane. I'm also quite involved in a cluster with Bluefield technology, with Mellanox, Arca, NVIDIA. And so as a whole, we drive a couple of local systems here in the computer science department. And then we have this guy across the road who's also here on the call, who permanently brings in new stuff. And we try to get this to integrate that stuff into our research. But Alistair will be able to tell you more about these activities later on.
Okay, speaking of Alistair, are you online?
I am, yeah. So I manage a DRI system at Durham University. So DRI is I suppose the STFC funded equivalent of Archer, which is EPSRC or something like that. And DRI has four locations, 3 services around the country, and there's one at Durham which we manage. And as part of that, we are usually on the lookout for new technologies to investigate, and we have our own test systems, test clusters, and so on.
And Robin, do we have Robin?
You do indeed. Am I? Yeah, you can hear me. So hello everybody, I'm Robin Pinning. Many of you will know me. I'm at Hartree these days, so Hartree Centre, part of STFC. This is a really deep subject actually, and with many different dimensions. So excuse me. So many different dimensions. I think that it's good that we've got RSEs on the panel. I think that a big part of this is understanding who you're aiming at in terms of your target user base, and who you're trying to accelerate the adoption of the technologies that you cover with. And I think that a big part of that is software. So this isn't just an infrastructure discussion. In my view, this isn't really a discussion about procurement, though that has a certain part of it, and how you liaise with technology companies and vendors. But it is critical that what's accepted today in terms of technologies, where things are going, and how do you move that software base to it. This is fiendishly difficult, right? So anybody who works in the exascale area will tell you this. But also, how do you incorporate AI technologies, other data technologies? How does quantum computing fit? How do you combine all of those in one workflow? How do you engineer any of this stuff? A little bit of background for Hartree. Hartree, our mission is to accelerate the adoption of all of these technologies I've just talked about in industry. So that's a very broad spread of different types of use. I'm glad that the topic of what's novel came up really early in this conversation, because to one person's novel is another person's sort of work a day. That's probably enough from me for the moment.
Okay, I think that's the whole panel, unless I've missed someone. I may make mistakes, but someone will shout, doubtless. So let's go to our first question. You have something that works. What is the inspiration to seek out something else? So Mark.
So I think we could just provide HPC services by just going to vendors and getting them to supply us whatever they've got. But actually, when you talk to vendors, you discover that they quite often don't understand what we want. And there are a lot of different technologies that appear that quite often are not targeted HPC, but may be useful. And a really good example actually is, I ran a European project called NextGen.io, and at the time Intel were just developing with a company called Micron something which ended up being called Data Center Persistent Memory, or DCPMM, and using a technology called 3D cross points. It's phase change memory. And the beauty of it is that you turn the power off and it remembers what you put in it, but it runs close to the speed of DRAM. And that's really interesting from an HPC point of view, but Intel initially just developed it for the commercial market. They wanted people to have in-memory databases that would survive a power cut holding your bank details. That's the real reason behind it. And we decided to bid for European money with Fujitsu and Intel and some European research centers to do HPC motherboard using that memory from scratch. It's the first time I've ever done a motherboard. It's an absolutely fascinating project, really enjoyed it. You do a motherboard for about $600,000, just so you know. And the main cost is actually getting the BIOS created for you by one of the companies like Amy or whoever. And it took us quite a long time, about 2 and a bit years to do it, but we were the first motherboard that's properly supported this memory. And in parallel with it, we were doing software development, so thinking about how you added features to Slurm, to schedule data arriving or being kept in the same place in a workflow using this memory. So it's a big project. And it's gone on to be sold as a product by Fujitsu. It's not transformed HPC like I thought it would, but I think everybody got a lot out of it. Intel certainly did, Fujitsu, and the research centers. And that's kind of at the extreme end, because those are big projects. And Europe was really good at funding those projects. They funded a number of them over years, sort of anything between 5 million and 15 million euros. And we have nothing like that in the UK today. So we're kind of, that's a shame. We do have smaller programs like the HNDS program, the Hardware and Enabling Software program, or I can't remember what the E stands for, but anyway, within the Excalibur program that's looking at smaller projects with devices. And I think that's useful too. But then my worry about that program is how does it then transfer into something that you would use in an X-scale system design? And I guess the rest of this panel will discuss some of that. I'll shut up now. But I do think this is fundamentally a very important and interesting thing to do, and it's what we as a community should be experimenting with at the hardware and the software level.
Okay, cool. I wonder if we could ask Tobias, do you have something to add, something to say on this question?
No, I very much like that emphasis on this scientific curiosity. I would like to go back and I would like to challenge the question, because I think the question is in some way already posed wrongly. Okay, you are asking, well, how do you convince people to go somewhere else if the old stuff is working? And I think in a lot of cases it's not working properly, and it will definitely not work in the next generation. So let me clarify what I mean is, if you look at recent reports, you can, for example, take Sandia reports or something like this, we see that our software is not really excellent in using the hardware that's there at the moment. And with every new generation, it's getting worse. And an example you all probably know is GPUs. You know, whenever GPUs come in, people use them, and you see these promises that they deliver 10,000 times the speed, but actually they're really, when we use them, it's really poor. So what I'm saying is the efficiency that we have with every new generation of hardware that's rolling in, the efficiency how we use them goes down, and so actually we just burn money, and that's getting worse and worse. So for me, it's not a question why do you not just stick to something that's there and works. What really drives me is that I think we do not use the stuff we should use it as efficient as we should use it, and we definitely won't be able, if we just continue to buy stuff off the shelf and just roll it in, then this is just not the right thing to do, both from an economic and an ethical perspective. And therefore, I think things like what Mark mentioned, that's really, really important stuff.
Cool, okay. So that's interesting. What's the opposite of novel I got from that? I thought, and I think the question implied, the opposite of novel is current. Maybe the opposite of novel is legacy. Maybe everything becomes legacy if it doesn't move into novel. So I'm going to go on to our second question. Then after this one, we'll see if anyone's got anything to say in from the floor. Just to warn you, I'm going to come to you first, Heather.
Right.
How do you engage an existing research community or a community of practice to try something new?
Yeah, well, I guess the easiest way is to give a free tutorial, because people always give it a chance if it's free, right? They think, well, it might be useful, it might not, so I'll go along and, it's half a day, a day of my time, not too much time to use up, and, maybe it comes in useful someday. So I think that's sort of an approach that I've used in quite a lot of contexts. The other approach is, of course, to give some sort of sales talk. You'll have to sneak it in somewhere. For example, I was talking about research software engineering practices at our departmental conference last week. So most of the talks were sort of very focused on statistical methodology, and I came in and talked about code and software. So sometimes you can get away with that. You take the opportunities you have to introduce ideas and spark discussion.
Cool. Okay. I'm going to see if Phil wants to add anything to that, or just say yes.
Well, I think there's a lot of good stuff there. I think, you need to know your audience a little bit. You need to know who you're trying to convince, and there'll be some people that if you convince them that's the right way, then they'll do it that way. There'll be some people who don't care what the right way is. They want results. And so in that case, you need to show them why you think it's the right way, what benefit it brings. So it's about why, if legacy software works, why would you move away from it? And some of it, as Tobias said, is, well, maybe it doesn't work. We just get away with it. Or maybe it works because you've learnt its weaknesses and you compensate for it. Or maybe it does work, it's absolutely fine. But if you want to run on the next machine we're getting, or the next technology, or you want to go and try one of the machines in the US, then you'll have to do some other platform. And that's the kind of thing with Excalibur that we're certainly looking towards. Some solutions don't work and some do, but do you want your research to stop in 3 years' time?
So I imagine a lot of people here will know about Excalibur. Do you want to say what Excalibur is?
So Excalibur is the UK exascale project. So exascale meaning 10 to the 18 in whatever measure you want to put there. So if you're a hard scientist, you probably think floating point operations. But some people will be thinking, RAM, storage, data generated per month. Scientists might be going, 10 to the 18 papers, that would be good. So it's 10 to the 18, everything computing related is the goal. And that's not just 1,000 times what we currently have, of course. That's also how that might be delivered, which is why some of these novel technologies are on the agenda a little higher up the agenda than they might have been. We were looking at petascale.
Actually, so I'm not going to disagree with you, but I will clarify. So there are 2 exascale projects on the go. Excalibur is focusing predominantly on the software side of exascale, although it's got a little hardware program in it as well. And then there's the exascale supercomputer project, which is the project to get an exascale supercomputer for the UK, and that's sort of separate. But the important thing is that Excalibur is doing both. It's doing the software thing predominantly, but it does have this novel hardware side to it as well, which I think is very interesting, and I've benefited from myself.
So, okay, in the context of a novel technologies and why novel and so on, I'm gonna ask the question, why exascale? And since you're here, I'm gonna ask you, why does the UK need exascale?
Exascale itself is silly at some level, in as much as
Stop you there. We'll write that down.
Supercomputing has always progressed by setting itself challenges, and getting to a sustained exaflop is the challenge that it set itself. I think it's a more interesting moment in time than previously as well, because we've always thought of a flop as being a full 64-bit flop, And what we know nowadays is that mixed precision is back big time, like it was in the 1970s and early 80s. So Exascale set itself this challenge, and it's able to meet that challenge. You know, there are good designs now that will give you an exaflop, a real exaflop on HPL for 20 megawatts, which is the design parameters that it set itself. But to answer your question, why do we need it? Supercomputing is also a bit of an arms race, and it's used by so many different scientific domains today, modeling and simulation. And all of our competitor economies are going to have access to that scale of supercomputing over the next 5 years. In America, they're going to have 5 exascale systems by 2025-26. Europe, they'll have 2 by 2024. Japan's already got Fugaku, which is half an exaflop, and the Chinese already have 2 operational exascale systems, the only in the world. One of them's got 41 million cores, incidentally, which I find quite amazing. So we're entering this exascale era, and my argument is that if we want to do science, computational science in particular, at the scale of our peer economies, we have to have access to that capability. And yes, that is a bit of a sort of willy-waving argument, but it is actually an argument about the importance of British science as well.
I think it's something that is worth stating, it's worth asking that kind of question, because that's the sort of question that appears in all sorts of chat rooms and sort of grumpy Twitter messages and so on. But, you know, the kind of questions about, you know, why does the UK have these ambitions? So it's worth asking, I think. Thank you for answering it. We can put that to bed now. It's fine. Anything in the room or online about anything we've talked about so far?
In terms of why would you use something novel or stop using something legacy, so even if it works, so the legacy thing that works that I was using, that I'm trying to shy away from now, is because the developer's no longer developing it. There's no development community there. It works, but if I find that it doesn't work in the future, there's not an easy way of fixing it, so I'm trying to move away from it for that reason.
Just a really personal example of that very thing. I currently have an Android mobile phone. Before that, I had a Windows mobile phone, which I had to abandon because it lost developer. And before that, I had a BlackBerry 10 mobile phone, which was the best mobile operating system ever. But that's also gone because it's not got developer support. So I think sometimes we're forced away from legacy, aren't we?
Yeah. There's loads of questions. Go on, Mark.
Just following on from what Mark said about exascale, I think a key argument, as he said, is it's the support for science rather than the fact it's an exaflop. So I think making the case that you were talking about in chat rooms when people ask about it, why do you have the ambitions? The ambition of just having an exaflop or whatever isn't the ambition. The ambition is the things we can do with it. And so I think that's the real selling point in terms of getting the funding, as Mark was saying.
Cool. Could I? Oh, Phil.
Can I chip in on that? Sorry. So I think there's with my sort of science hat on, there is a perception maybe that the exascale means bigger simulations, and there is scope for that, and more complex simulations. So the point where you're not simulating a model of a thing, you're simulating something really quite close to the real thing. But there's something else which comes in, which is if we could really use an exascale machine to get things done, say 1,000 times faster than on a petascale, you can start to run things like simulations in a responsive way where they can be part of your design process. So you're not taking some thing that an experimentalist has said, can you simulate that? Yes, it agrees. Great. With a 4-month lag, you'll be able to take something and simulate it and then go, oh, what would happen if I tweaked it some way and simulate that? And you can actually be part of the whole design of the entire scientific process in a way that you can't easily do with things that take weeks or months. So it enables a whole way of working that currently is kind of closed to us, if we can get everything to scale to work on the machine.
Yeah, I think that's a really good point. I mean, if you look at what the work that's been done on Summit, and it's a good point good time to look at Summit at the moment because it's towards the end of its life. They've got a whole load of really nice science stuff on the Summit website. And people have done things on it. A really, really good paper I read did a massive genome-wide association study on Summit, which, yes, they could have done it on Summit before. They would have had to get the whole system on the pre-test Summit for 6 months. You're never going to get that of the national supercomputer. But Summit did it in, I think, a full day of Summit did this study. And you need to think of these devices a bit like that, actually. Yes, things are possible, but there's this compression of time argument as well, and because you're just never going to get the national system for more than a day, I think.
Cool. So this relates to things from the previous session about being able to have your kind of research process and these tools fitting into the process rather than having to wait for a month. Online, Marion, you got some things?
Yes, people are chipping in examples for what exascale could be used. So Peter is saying uncertainty quantification of expensive simulations, and James is saying real-time digital twins.
Cool. James.
Thanks. So I wanted to contribute on the question of adoption of new technologies for new software platforms within laboratories. So you often see research groups continuing to use the particular piece of software that lab has used and been developing and doing little bits of contributing to for a long period of time, persisting even when there may well be more valuable, better suited tools. We see situations of each lab maintaining its own software rather than coalescing around a shared platform. You see people creating new platforms rather than contributing features to existing platforms, and all of these things are part of a perverse ecosystem around research software funding and research funding. It's easier to get academic credit for being the person who looks after a particular code with your name on it, rather than by contributing features to a shared platform, which is one of the failure modes. I would like to see support for research groups to delete their codes. So funding you can apply to transition your lab from whatever software it's currently using to, and this requires retraining your postdocs and PhD students with the new software, requires familiarization effort with whatever you're transitioning to, and it requires some support for lost academic brownie points because you're no longer the lab where such and such a code is looked after. But if we could make a code sunsetting fund or a software lack of sustainability institute or something like that, it might help with some of those problems.
Cool, thank you for that. That's I wonder, in the world of business, they call that merger, don't they? Where something small dies and a big thing takes over. But maybe there's a concept of that. Maybe you don't just give up and adopt someone else's thing. Maybe you join the someone else and contribute to their thing. And then you've still got your name on something. It's just, you're one of the 74 CASTEP developers or something.
I wish.
Before we carry on to our next question, I thought I might do something slightly novel, since it's the novel technology session. In the principle that there's probably 50 questions in the room that aren't being asked. So on your tables for about 2 minutes, talk to each other in the don't have to speak out in front of an entire room situation. Talk about these questions, any questions you have about it, things you don't understand, things you wish you'd asked but didn't. And then someone confident from your table may ask the question or give us a summary in response. So I'm going to keep it to like 2 or 3 minutes, but go. No. Yes, we're at table.
I think James's idea of retiring codes, you imagine a bunch of mischief at your door with burning pitchforks.
Okay, so before we move on to the next question, I promised that I'd give people an opportunity for the kind of things you just talked about, things you think other people would like to hear, or questions that came up on your table that you think would be good to say. Anyone want to share at this point?
Well, we've got very two very good ones here. I volunteered to do the talking, and these guys did the thinking. So the first is, where do I get the funding to do the code updates to keep up with all this novel stuff? And the other one is, how is the storage going to keep up with all this novel stuff?
That's interesting. There's an EPSRC call out right now, I think, for maintaining existing software. Is that true? Someone in the room must know about that. Yes, Billy. Just saying yes.
I'm just saying yes.
Okay.
It's been out now.
Has it closed?
Yes.
Oh. Okay. Well, that's good news. We want more of those. Can we have more of those? Excellent. And anyone else want to comment? Anyone up here want to comment? Anyone online panel members? Do you want to come in at this point? Anything to say?
I think with regard to the storage, I think that's an interesting point, because we're at an interesting moment in storage in HPC. Right? Are we going to continue using more and more Lustre? Our users want S3 interfaces to storage a lot of the time nowadays, so are we moving to more Ceph? But how then do you get performance? So there's lots of complexity around storage at the moment, and storage actually has been quite dull for the last decade. I think it's about to go through a much less dull phase, if you want my opinion.
I think we do. That's why you're
Mark. It's me, Robin. It's an interesting point, that, Mark. I think there's two aspects to this. Well, at least two aspects to this, and that's okay, so when does storage become part of the memory hierarchy? You know, and there's varying different ways you can look at that in terms of speed, latency, etc. And also, okay, so are we considering just codes, or are we considering a full workflow? In which case, you know, when does HPC converge with cloud and cloud technologies and that usage mode? That's, to some people, that's a controversial subject, and it might be one worth discussing at some point.
Yeah. Should we do that now? Should we discuss that?
Well, we had a panel on it.
We had a panel on it. That's true. Okay.
Oh, did you? Yeah.
I would. Oh, sorry. If for maintaining code, I mean, it slightly depends what people mean by that, but certainly things like the embedded CSE, the Archer ECSE, in terms of taking code and changing sort of well-defined parts of it to improve performance or sustainability, that's been very useful. If it's, I don't know, if it's fixing bugs, I don't know how you fund that.
Yeah, I think that's an important point there about, you know, can you, with faster and faster architectures, can you afford further abstraction away from those architectures, and what does that buy you? And what does performance portability look like in those scenarios? So we're doing a bunch of work with the Met Office around this to keep their code going over a number of different architectures, and whatever comes in the future. You know, is that something that most scientific code bases want? Is that a route they want to go down? It's understanding the trade-offs there as well as the benefits.
Sure. There's the dream is the write it once and run it on everything, isn't it? That may not be easy. Louis.
Where I was coming from more with the maintenance of code was, we have software, it relies on external libraries, those libraries get updated. In order to keep our software running, we have to update the code to accommodate those. And where do you get the funding to be able to keep up with that, basically?
That's a good question. Yes, I mean, we run over 1,000 different bits of software on our HPC system. Some of them are libraries and dependencies. We upgraded recently from Red Hat 7 to Red Hat 8, and the glibc changes alone, there are breaking glibc changes, and the number of pieces of software that wouldn't even compile without us patching it, and the number of commercial codes that do not run. So if you use Abacus 2017, won't run on Red Hat 8, and various other things. Red Hat 8, is that novel technology? Well, it is in our community, I guess. Certainly 12 months ago it was novel. I'm going to go on to the next.
May I make a comment on that? Where does the funding come from? So it's obviously we can all we can try to complain to EPSRC or whatever that we need more funding. That's one way to do it. I mean, you all know EPSRC, that might only get you that far. The other thing is, to some degree, we might ask ourselves whether we have failed to bring the right people in. We are quite used to buy off the shelf what vendors kind of throw upon us. I mean, the biggest example is GPUs, okay, which now they're just there and they throw them in, and then we do all that. So we might ask ourselves whether we have failed to some degree to push stronger towards a co-design approach, where we approach people who want to sell us something and say, well, if you want us to use that, then we need your support, because it starts earlier, okay? It starts with the software stack, and then it continues. And I would like to see more real collaboration with people who build hardware and want to sell it with the scientists, so we can make the best use of that hardware. And I think this interaction is underdeveloped in the UK, worldwide.
So there's a couple of things you touched on there that I think have been themes so far. So the idea of like working with your vendors to install a system, but also working with your vendors when they're designing their new system. There are working groups that talk about new stuff. One thing I keep forgetting this, and just looking up and seeing Nikki makes me think there will be a fire alarm. Okay, it will happen. I know you were pointing over there, but just seeing you again, you've said to me like 5 times, don't forget to say this thing. So hands up, I'm not very good at this. The other theme that I was going to say is, somebody mentioned in a session, I think it might have been yesterday, when you're developing your website or whatever, how do you deal with future maintenance of that software? Well, how do you deal with future maintenance of your scientific code that may need to run on new software? What do you put in your grant? How do you work with the funding council who wants to say your grant runs from now to now and the money turns into a pumpkin on the 31st of March, when you still want to be able to do stuff? Right, yes, Mark.
So just following up on the comments about co-design, I'd just echo what was said, that I think working with industry on this is really important, because what I was going to say before Tobias brought it up was, the point you made about the Red Hat 8 transition. It's really highlighting, it feels at the moment like all of our systems are a lot flakier. Our overall ecosystem is flakier than we would like it to be. And that we're, as we get, we've got all this diversity of hardware that we want to take advantage of for research, but it seems like lots of things like the interconnects, the software stacks, not everything's keeping up. And we need to be involved in that process, so that maybe it means narrowing down the things we consider, but at least we've got to find a way of doing it, because it can't be that every time a new operating system upgrade comes out, services go offline for weeks. That's ridiculous.
So I agree, and I think it's interesting to look at what happens elsewhere around the world. So if you look at Japan, I won't go into China, but China's quite similar, and the US and now Europe, each of them's decided that investing at the very high level of supercomputing is a way to bring benefits generally to the IT economy of their country. And America's been doing this for years. So as you sit with your PlayStation or your Xbox Series X in my camp, the processor that's in both of those was developed using some of the exascale money from about 7 or 8 years ago. So the changes, in particular, that AMD made to their processor design structure, which is now in AMD Rome and everything, was funded as part of the US exascale program. And America's been bunging money at its silicon vendors, particularly NVIDIA, Intel, and AMD, for the last 20 or more years in this way. And in the UK, in fact, we could do this. There's no reason why we cannot do our own processor in the same way that Europe's now doing its own processor through Cyperl, and Japan did its own processor with Fujitsu and the A64FX. But what we need is a government that understands the importance of investment in this area, decides it's a priority. It may not be a priority, but if it decided it was a priority, then understands that they have to invest for 10 years, because it takes 10 years from beginning to end of one of these programs, and then you roll forward. I personally think it'd be a good thing for Britain to do, because we're really good at silicon design, and we're really good at operating these big systems. What we don't have in the middle is an industry that can build at scale this sort of technology. I think we should do it, personally.
Vote. Should we do it? Hands up if we should do it. Oh, yeah, motion carried. Okay.
There's an interesting point buried in this, though, isn't there? Is what is valuable to the nation, to our nation, and how do you make that case, right? So to the flavour of government that you have in at the moment, do you make it on national security grounds, because that's really high at the top of the priority list at the moment, for various reasons? Do you make it as part of you're going to inflate the economy and drive national income to higher levels, quality of life? We've got to make the case. We haven't so far. It needs significantly more investment than we're getting at the moment. I really do support that idea of you need at least a 10-year program, to do this stuff. Where we are in the UK at the moment, it is always in dribs and drabs. There's numerous people in this room who've made cases for their individual centres, and it's always, it's always less than you'd need to actually have this to be a sustainable endeavour. And as a nation, we need to change that.
Right, thank you for that. I think we agree. So before I go on to the next question, anything in the room, anything online?
I think James had his hand up.
Still?
I did, but then I thought better of it. But since you said that, so there's another thread to this lobbying government piece, which was quite difficult when I was in UKRI. The UKRI leadership would like us to be in a position where we are lobbying government for investment in science as science, and then we use the UKRI processes to determine how we divvy up the science budget and the question of how much of it goes on health research and how much of it goes on a digital research infrastructure, and of that, how much of the digital research infrastructure budget might go on exascale capability would be holding principle following, ring fenced inside the scientific community. And what we're doing is we're lobbying to government for the overall science investment. It's clear that hasn't been working. Right? It's clear that the all the arguments that Mark's just been making require us to be specifically talking to Bayes and DCMS about scientific computing in particular. But that doesn't sit well with some of the other principles around how we would like UKRI to work. And I think that's also a part of the tensions that are making this difficult at the moment, and it'd be good to be at least eyes open about those challenges, and as we think about how to engage on those issues. Over.
Okay, thank you for that. I guess one good thing about this community, we have a few people who are in a position to talk to UKRI. You're one of them yourself, James, but in a position to talk to the people who can affect policy on this. So anyone else in the room who has thoughts on that? There are guys here and people here who can do that. I think there was a question over there or a comment.
It's a new question from the chat, but if anyone else has a comment on the old question, let's do that first.
Okay, we'll parallel. We'll do it all in parallel. Carry on with that question.
Okay, James is asking for any comments from the room or panel about driving towards using containers as software packaging standard.
You're nodding a lot.
I am, actually. So we're trying to do this at the moment, and the Shasta operating system is containerized. But certainly the operating system level, and the idea is that over time more and more packages on Arch 2 will be using containers. But And Mark said he would walk out when I was speaking, so that's beautifully timed. I think the other thing we're trying to do is we've got this data infrastructure, which is a virtualized data infrastructure, which is using Kubernetes cluster at its heart, with academic users in Edinburgh able to do a container on their laptop, bring it in and run it on that. I really want them to be able to take that container and then put it onto our tier 2 system with all the V100s. And we haven't got this working yet, but that is absolutely the direction of travel, and I think it's going to transform how we converge HPC and data science. That is the vision.
So you're in the tension, aren't you, there, of portability versus performance.
And it's very tense in the systems group, I can tell you.
Yeah.
It's difficult to do.
So we have our Power 9 system. We've just installed, there's a note there, but I can't remember. Yeah. We have our Power 9 system. We just installed Chemu on it to be able to run x86 codes on Power 9, which is not going to be as performant unless it's just running a bit of x86 and mostly NVIDIA GPU code. So, but that tension of containers and I am going to go on to the next question. So warning, Alistair, this question is coming to you first. I like giving people warning. Now I'll read it out. Who needs to be convinced about switching to something novel or getting permission to do something novel, perhaps? And how were they persuaded it was worth doing?
I think it all comes back to the science, doesn't it? If your science is fine and you're getting results that you need on the system you've got, then there's no reason to be convinced. But if you have the sort of science that benefits from novel technologies or larger systems, whatever, that's what convinces you to make the change. And then if you are in a science community that is kind of cutting edge and leading the way and has the effort to be making use of these technologies, you're then able to begin to identify technologies that would be particularly helpful for your codes, whether that's different networks or whether it's different categories of RAM or different ultra fast storages, things like that. If your community is able to benefit from those, then you can begin to feed that back into the into the infrastructure and ideally have systems that are designed to work to run your codes well.
Cool. So I imagine that people will mostly agree, but do you want to say something, Heather? You're leaning forward.
Oh, well, yeah, just...
You might just be leaning.
No, I was agreeing with that. Yeah, I think that's often a big motivation, isn't it? If you can do something more efficiently, then you save time, or you can work on bigger and more ambitious projects. So that's a good motivation for researchers to switch to something new.
If I could add a note of pessimism, though, there are certain, how can I put this? There are some fields, some communities, where the people who take strategic decisions about what software should be used are not the people who use or write that software. And so there are certainly situations I know where if you talk to a PI, they'll tell them we want to run this package because we always run that package and it all works. If you talk to the PhD students, or if you talk to the guys somewhere like EPCC who have to support the software on something, they tell a very different story. So it's worth thinking a little bit about how we assess the health of an application beyond just, it gets me 10 papers a year, I'm delighted with it. Well, yeah, but who? It's the sort of the swan argument. How furiously are the legs paddling beneath the water?
Yes.
I was just going to add to that. I think if you look at the papers that win prizes at ISC or supercomputing or whatever, you see that Europe is not in that game nowadays. And it's because people form consortia just to do a code to do something spectacular. And all of the papers, the most impressive papers, people are thinking down at the moving half a byte around and their memory layout and all this so they can squeeze the last bit of performance out of the GPU or whatever. And it's beautiful, beautiful work, but it's exactly at odds with what the research software movement has been telling us for the last decade, which I'm part of, we're all part of. And I think personally what I would like is us to do some of that stuff too, but not drop all the other good stuff that we're doing. And we just don't do that side of things in Britain any longer. And they really don't do it in Europe either. If you look at the papers, there's very few papers in Europe that set themselves. In the 1990s, I think we called these grand challenges, if you remember. I'd quite like us to do more of that in the UK again. I don't know how other people feel.
So we have a question or a comment?
Yeah, a bit of a comment, maybe a bit of a naive one, but who knows. It was on the subject of how to get people to adopt like these new technologies, and talking about efficiency savings and things like that can work, but sometimes the best motivator is people's wallets, right? So in retail, you've got this concept of a loss leader. So potentially as an idea, just a good way to convince somebody to use your hardware is that we'll give you more bang for your buck for the early adopters, and then sort of in time, ramp it back up to something that's not going to lose you a bunch of money, but try and bring people on board by giving them better value than they'd get using legacy hardware.
That's interesting. So from our perspective, people who run systems like that, maybe we have a kind of discount on the funky new resources. So you're all using the old standard queue. If you want to use this new one, you're going to have to re-engineer a bit, but you can have it for half price or something, 6 months.
Yeah, sort of to add to that, it's like we talk a lot about the sort of inertia on getting people to move away from what they're used to and what they are comfortable with and currently running. And I mean, you want to build that inertia on the system that you are offering them, right? And I suppose that's kind of a way of doing it. Like I was kind of analogous, or I saw something deeply insidious, which was a vape company at a festival giving away free vapes. And it's like, well, I mean, they're really addictive things. You get a few for free, and the idea is that they then want you to just purchase their vapes forever. I feel like offering good, novel HPC resource is somewhat less insidious, but I think it could be a similar way of getting a degree of reliance, because at the moment we complain about people not wanting to move away from legacy hardware and software, but if they were to get onto the novel software and hardware, they wouldn't want to move away from it either.
Yeah, so that's good. I think it's good to be clear that we're not kind of drug pushers in this. We have seen something that we think will be genuinely valuable to the scientific community, and we want to help them to be able to use it. Okay.
So just to add on to that, I do know that a number of years ago, maybe 5 or 6 years ago, NVIDIA were in the habit of giving away graphics cards to code developers. Not to supercomputing centers, maybe they did as well, but to code developers, in order to encourage code developers to port their code to GPUs, because they knew that that was going to be the direction they wanted to push that. And so they were giving away sweeties to the code developers, saying, no, if the problem is that you don't have the hardware to port your code to a GPU, we'll give you some quite sexy hardware, a few grand's worth, so that you can do that. And then hopefully then that'll help persuade all the supercomputing centers that they should invest in big bucks in our hardware, because your codes will now run on it.
Yeah.
Well, I don't know about that. So I'm sure they're in it for the money. So they're giving away sweeties to the code developers to persuade us to make those changes. The other thing I was going to say about was in terms of incentives for changing your hardware. There was a number of government schemes some years ago for upgrading your hardware to new energy efficient hardware and getting financial incentives for doing that. And I wondered in terms of novel tech, I mean, one of the things that Mark mentioned a while ago was about the exascale goal in terms of a floppage and also a wattage. And the whole idea of energy efficient computing, I wonder if the panel had something to say about novel technology in terms of hardware and software to get energy efficient computing. Because if we just scale up the teraflop systems, we'll never get, or petaflop systems, we'll never get to exaflop without having to have several power stations to drive our supercomputer centers. So obviously that's been a big driver, is low power computing. I wonder if there's something to say about novel tech, hardware and software, and low power computing.
I could say something about that. There was something online I think we'll come back to afterwards, but we've got an Excalibur project for an accelerator, which I can't say very much about, but the whole goal of it is to achieve the same task for much less power. Once the hardware arrives, we'll tell you how well it functions. Online comment?
Yes. we've got the question here. Would people agree that the concept of RSE needs to be reimagined in relation to novel hardware? Earlier in the week, RSEs were being described as people who rock up in a team, impart some knowledge, and leave again. Surely, if hardware is truly novel, it implies that there is no persuasive use of HPC use case at this point in time, or limited expertise regarding the hardware within the RSE community. Supporting novel hardware often requires the writing of new, highly experimental libraries, with the possibility of failure, significant lost time, and industry developer support. RSEs fit in here, but I didn't get the impression this is part of the DRI movement self-conception.
I don't think that was an intentional impression that was given, that an RSE just, rocks up, spends 3 weeks somewhere and disappears and you never hear from them again. I think the point, if I can go back to one of the kind of the founding pillars of the RSE movement, it was about software sustainability. And it's a huge challenge, I think, of all technologies, but I think it's the goal. The challenge is it's not just the hardware that's novel. It's the way you drive the hardware from a software perspective. And if we just take GPUs, there are at least 4 standards for how you might use them. And they are, most of them, tied to a vendor, either hardware or a compiler vendor, they're not what most of us would call standards. And possibly none of them are the answer long term. So that's a real sustainability challenge. But that's not to say we're writing unsustainable software deliberately. It's a challenge that we face, and we need to move forward as a community. I would like to pick up the co-design idea and to say we need co-design with the software framework people as well. And it's not just going all the way to the chips, but it's also, I need to not have to have a project to port code from Pascal to Volta or from NVIDIA to AMD that involves rewriting everything that I did before.
Yes. And the rewriting's not always that fantastic. If you run the PyTorch unit tests on a GPU versus a CPU, some of the functions have different answers. Did you know that?
Yeah, I was going to say, Tobias said this at the start actually, I think that on any system today, the processor spends 95% of its time waiting for data. And I am old enough to remember Amdahl's 3 observations, one of which is basically to build a well-balanced computer, you need a certain amount of data to appear at the processor at a certain clock speed. And we have forgotten that over the last 20 years. We've become seduced by HPL. That's not going to change, unfortunately. Japan's done it really well. If you look at the Fugaku system, it's got the most fantastic bytes per flop ratio compared to other systems. And as a result, although it will quickly fall down the HPL pecking order, I predict it will stick very high up the HPCG, this other more realistic benchmark, for a long period of time. And I think that's the value of the Fugaku system being designed by silicon engineers and the science community with their applications. And we don't have that option in Europe, in the UK at the moment. In order to meet the power that we can realistically spend on an exascale system, and this is true in Europe, the US, and the UK, 25 megawatts of power, it's going to cost £40 million a year. It's a significant power bill by any measure. And the systems that exist will have GPUs in them, whether we like it or not.
And the new NVIDIA ones are 700 watts each.
Yeah, exactly. So, dangerous levels of power. In Archer 2, we're at 150 kilowatts in a rack. For some of the next generation of racks, we'll be at 350 kilowatts in a space that's 1 meter by 1 meter. It's really dangerous, actually.
Yeah, so what's 350 kilowatts? That's 100 kettles in a space the size of this table.
Yeah.
Okay, good. That'll be fine. I just want to check in with our online panelists. Is there anything you guys would like to say at this point?
A quick comment around the NVIDIA giving away graphics cards. I think that they would argue that they're pushing a new standard in development there. So it is related to Mark's comments before around containerization, and actually they do push this concept of developing on your desktop with a GPU and then being able to move it onto one of their super pods or whatever, which is quite an interesting idea. Whether you get the full performance is another thing entirely.
Okay, yeah. Tobias or Alistair, you want to bring anything?
Yeah, one thing that's problematic with that, and it's very difficult to solve that, but very often I think it's the algorithm and the scientific approach that are not a fit to the hardware that we get. So again, this GPU stuff, okay, they're made for certain applications, and they're certainly good to simulate blood as it spills when you have your ego shooter, but they're not good for a lot of the novel research that we do. So in some degree, there is this massive gap. Okay, what vendors give us, and what we would like to do algorithmically, and basically the way it works right now, besides Fugaku probably, is that you have that, you buy it off the shelf, and then you have to adopt your algorithms and actually very often pick inferior solutions. And I find that totally disappointing. And it's exhausting. It's exhausting that you speak to salespeople and everything works, and then the cabinets roll in, and that's where the work starts. And there's not really support for that. Also, to be honest, there is not the right level of training available for that. If you speak about, and I mean, if you speak about hardware, okay, where is all the RSEs, PDRAs, PhDs that can do proper C coding? Well, they basically fade away because we train our students to do Python, and everybody wants to do data science because that's fancy, but we lack the expertise. Where is the computer science degree that teaches containerization, that actually teaches proper hardware? That's also, in my opinion, well, it's my impression, it fades away, and this is really, really dangerous. So we're not in a good position at the moment, I think, to do that stuff.
So we've got a question in the room. I'm going to come to you in just a sec. I just want to say, as someone who has some power over what goes into courses in this area, anything you'd like to add?
Oh. No, I need to think a bit about that.
Okay, that's fine. Question over there?
Okay, so we'll go back to something slightly earlier and think about sort of ecosystem. We're talking about novel technology. Quite often the waste from one process can be used in another process or in another part of the system. And when we think about net zero and we think about the energy requirements for running these machines, it's sometimes this waste heat, they deal with that problem by making the computers and installing the infrastructure where the latent temperature's low, but that's wasting the heat to the environment. If you can use it to heat people's homes or a swimming pool, or think about that kind of thing, this is the way forward to try to think about how this whole system-wide approach can work, and to have it so that things are inputted into each other in productive ways.
Yeah, that's a good point. I remember when I was 10, I went on a tour of Sellafield, and they were explaining how the whole system worked. They're saying, and this is where all the waste heat goes out. And I said, can't you use that for something? Because you need heat to kick off the reaction in the first place. And they said, no, it doesn't work. You've just got to vent it to the atmosphere. So what can you do with the heat?
Well, until recently, the waste heat coming off supercomputers is actually pretty low grade. That's one of the fundamental problems of it. So Archer was, I think it was, the original Archer was the off the coil was 14 degrees centigrade. It was coming off at 18 or 19 centigrade, and you can't really do very much with that sort of water. However, modern systems are generating the water up at about 40 degrees as it comes off the processor. And the plan for the exascale system, which is at lunch, is we're going to build a heat battery using old mine workings underneath the data center. Just happened to be there. I didn't know they were there, I now know. They're very extensive. It's actually a river that runs in the mine workings all the way to the south of Edinburgh. And we'll heat the rock up, build a heat battery, and homes and businesses will be able to take that heat out to heat themselves. And we're actually going ahead with, just got money to do the first 2 big bores down into the ground to do an experiment at the extraction and injection point for the water.
great. Just to say that the Lumi one that they've built up in Scandinavia is a great example of a system which is providing this sort of eco approach where the heat has been used as a district heating scheme, I think, for residential.
I suppose there is the question what you do with the other 6 months of the year, though, where you don't actually need the heat.
Well, the beauty of the heat battery is during the summer you're
which tends to, I mean, swimming pools might be a solution there. Lots of swimming pools everywhere.
So I agree. I think that one of the challenges we can't do that up at EPCC is there's not very much around the ACF. It's in a field, and moving the water around long distance is difficult. It cools down too quickly, and it's very expensive to do the insulated pipes. So this heat battery is better because it will build up over time, and over the summer you can just heat the rocks. People don't need to take it out. During the winter they can take it out with heat pumps. It may not work though. So
could you put an HPC machine in the basement of every apartment block in a city? And you've got a distributed architecture then across the city.
I think the problem, Robin, is that a single rack is going to generate too much heat for buildings.
I know, it's the trouble, isn't it? Yeah.
Yeah. An Exascale system will have 60 racks, so 20 megawatts by 60 racks. Right, that's a lot.
Yeah,
of heat.
You're too distributed then, aren't you? Basically,
Exactly.
I joke about this, but I did talk to a startup once that they were genuinely considering what it would be to have instead of your boiler having some kind of compute resource that thrashes away and heats your house. But then it comes back to Alistair's point about how do you cool things down then?
Yeah, computer heating your house is the perfect example of heat when you don't want it, isn't it? But, James.
Thanks. So much more prosaically, coming back to some of the things about adoption of the new we were talking about earlier. Mark alluded to some of the controversies in his team over the adoption of Docker for HPC systems. We are still running Grid Engine using venerable technologies like XCAT. Largely because I have sysadmins who've been happily using those particular technologies for years and would get a little bit on the squiffy side if we told people they had to, we're going to shift all the things to some newfangled WAS name. How do we become more forward-thinking as a technology community and avoid being fogies within the HPC sysadmin community? Over.
That's the novel for whom question again, isn't it? What's novel for my sysadmin who's done the same thing for 30 years is different from the guy who's just bought a undergrad who's playing on a computer in his basement. Comments? Okay, Robin, warning, I'm coming to you next. Since I can't see the online guys most of the time, I can either see the questions or I can flip to the online guys. So I'm coming to you, Robin, with this one.
Okay, cool.
What grounds the exploratory activity? How do you ensure it doesn't? I'm going to start again. What grounds the exploratory activity? How do you ensure it doesn't become self-indulgent?
Interesting phraseology on this question. So I think that some of this is really understanding your mission and why you're doing what you're doing. So, and I guess I'm talking from the point of view of a large technology centre. Understanding who your audience is for that. So you've got the culture of sticking to the mission. Now, really understanding the challenges of your users. It's not just the nature of the users and assumptions about that user base. You can make assumptions. So in a university, you can make assumptions about your user base looks like, maybe 5 different disciplines. And actually, as an HPC service, say in a university, then there might potentially be 15, 20 different disciplines that could be using that facility. So that's a similar way of focusing minds around this. There's another interesting point about novel technologies here as well, in that as technologists, and we'll all understand this in the room, we can see we think we can see where the technology is going for our particular our particular users and those we work with. There's a danger in that you can assume that this is moving quicker than it actually is. So you really do need to understand the full environment, but also understand what's timely. It's very, very easy, and I'm sure we've all done this, to sort of make a prediction and then try and shift a user community over too early. And then that effort flounders. So I think that, you know, focusing on the challenges at hand, but also with one eye to the future is how you actually how you ground the activity. Any questions around that? Actually, it's an interesting one to discuss, this one.
I think one way to get better value from these investments, particularly the H&ES ones, where it's quite small amounts, it's a couple of 100K, is to, as part of it, have to give users who ask nicely and want to be pioneers access to that hardware. And I'm not convinced, I'm looking at Billy here, I actually don't know the answer to this question, whether or not it's built in at the moment that you have to give external access or not.
I think we're still on internal access.
Yeah, exactly. So it's and I think some value, even if the internal access was for the first 12 months, but then the person would agree to keep the server running for a bit afterwards to allow other people to have a play, I think that would accrue more value to the investment, actually. The challenge, of course, is you're not running a service. These are not easy to use things. You're just basically giving somebody a login and saying, you know, have a play. But I think there would be more value if we could approach it a bit like that.
So there's also we've seen some uptake of that offer for our H&ES facilities, but actually very little really. So, you know, and I think it goes back to the effort question, doesn't it? People don't really have the time to be looking at this when they're trying to get their papers out.
You know, I mean, the main...
Plus, often it's quite disappointing experience. I mean, you know, you roll in a new piece of kit and you have to accept that the software stack usually isn't there. And everybody who tries to compile on a big supercomputer with different MPI versions and libraries and whatever already suffers. But if you go to a machine where the hardware is brand new, you can kind of assume, I mean, how many weeks do my guys spend on recompiling the compiler? It's quite disappointing. It's really a lot of effort.
But if you like that sort of stuff, it's good fun.
So coming back to, I don't know, you might get bored with this, the novel for whom question. Really cutting edge stuff might be hard to get hold of. For a lot of people, the stuff that is now in tier 2 systems is novel. You know, your software may not run on that yet. You can get access to those systems and you can work on getting your software to work on those systems now. There are regular calls for those. You can also email someone who you've met here and say, I've heard you've got a blah, how do I get access to it? And what you might call the Martin Guest approach to a career. So we are a community, and if someone has access to one of these things, there is a good chance that they will share. Right, I have got 10 minutes or so. This one's coming your way, Phil.
Okay.
What balance do you aim to strike between production evolution and revolution exploration?
Oh, okay. Well, in true HPC fashion, I think you parallelize over both of those. So there is a community that says, oh, you throw away your code and you start again when you get a new technology because that's how you exploit it best. And I'm coming from almost the opposite point of view, that the code I develop mostly is something like 2/3 of a million lines of code, and I'm not going to throw that away and write it in CUDA and also throw it away and write it in I don't know, SYCL or something, data parallel C. But what you can do is you can identify important kernels. So if you understand the code and you know where it spends its time, or you know which bit you want to extend, it depends if you're after performance or new capabilities, then it can be a much easier problem. So the evolution can be a very sensible route. If you've got 2/3 of a million lines of code, but you know that actually when you run it, there are 1,000 lines that take 99% of the runtime, well, focus on the 1,000 lines. The other thing you can do, and some of this has been done in Excalibur, is you can think about writing a much simpler toy version of what you do that has the key things wrapped up in it. It doesn't even have to be in the same language necessarily or using the same libraries. And we're using that kind of thing to explore new ways of tackling a problem in something that's more like 5,000 lines instead of 500,000 lines. And it does mean you can throw that away and start again very easily. It also has the advantage that, as far as I know, no strategic investment in science hinges on whether our mini app works or not. You can break it reasonably low risk. So you can have your completely revolutionary way of doing things and thoroughly test it, break it, rebuild it, and still have the production stable, big code base. And that's the way we're trying to tackle this problem. You have a big code base, big user base, there's a lot of inertia there. And you only want to move if you know it's a wise direction to move in. Because you need people, and you need all the developers to buy into it, and you need to be able to convince them that it works. And the best way to do that is to have done it in some toy sense. And to say, look, you might think this is going to be impossible, but actually it took this long, and we get this performance, or we get this capability. So I guess I'm saying don't compromise, do both. But I mean, there's obviously some tension there. But I think you can do a lot by just saying, what are the really important things I need to do? Just to tack onto that, I've talked about Excalibur a lot. I'm involved in Excalibur. But when we talk about novel technologies, for me, GPUs are novel because exascale computing is probably going to be delivered with accelerators of some kind, which might be GPUs. But you might have a workstation with a GPU too. This isn't just the people who are going to use an exascale computing. This is people who are going to use, we might get to a stage in 3 or 4 years' time where you might be seriously considering a new workstation. Should it have some kind of GPU? Should it have an FPGA? Am I going to be using your sound card? Whatever. And what's novel now will be what you're just getting in your Xboxes and your PlayStations in 5 years' time. So,
yeah, I think that's a really good point. And I think that the interesting thing actually isn't about GPUs and exascale, it's about what's happening with the memory model and GPUs. And so all of the GPU accelerated exascale designs for 2023 onwards use, in fact, NVIDIA's now announced it last week, the Grace Hopper. It's a single address space for the first time. So the GPU and the processor cores share the same data. You're no longer be using, much of CUDA is actually dedicated to moving data around in various different ways. All of that is going to go, and I think it's going to have, it will involve quite a lot of software work and algorithmic work, but we may be able to find more grunt out of the GPUs with some thought. I think it's actually going to be quite a big software transition, this, and it's not just the normal, am I using SYCL or CUDA or was it ROCm on the AMDs, and I forget all the things. I think it's going to be as much about memory and how we deal with how we're presenting the data to the processors on the blade. It's very exciting, actually, I think.
Yes,
yeah, I sometimes feel that the term software sustainability doesn't really help. Okay, and it's actually stopping us from doing stuff. We might, maybe that's heretic, but we might be forced to rewrite everything every now and then. It's a different thing, and that's not a problem. The problem is that a lot of our knowledge within the software and around the algorithm is not reusable. So rather than thinking about software sustainability, where the same piece of software evolves over time, maybe there is also more to be invested into algorithm and idea sustainability. So how do you present your design rationale, your design decisions, your algorithmic ideas in a way so that others can reuse them, re-implement them? I know there's a lot of emphasis in journals like CISC or TOMS that you present the stuff that so others can reproduce your software, reproduce your results with your software. But maybe that's the wrong ambition, because people will never ever reuse your software. They want to integrate your ideas if they are cool into their own stuff. And maybe we lack a little bit of the tools and ideas how to do that in a more streamlined way.
Okay, I've got about 9 ideas and about 3 minutes. So I want to go just to check in with Alistair, I think, for a different, potentially different view on the idea between sort of sustainability, production versus innovation and exploration, and how do you strike a balance? Which is this question we started talking about a minute ago. Alistair,
Yeah, it's, how do you strike balance? I think, yeah, it's a big question. I think code efficiency is where we're going to have to be putting more effort in the coming years. You know, codes tend not to be very efficient. They tend not to use hardware very well. User education as well. You know, we still see people that catch people occasionally using a single core on a 128 core node, things like that, which obviously is not very efficient. Now, in terms of how you design your system, I think you have to take a lead from what is available, obviously, because you can't put huge amounts of effort into developing something yourself. But at the same time, you have to be cost effective. So you can't go right to the forefront for the large systems we want to put in. You probably can't. You recycle water, and you can get.
I'm so sorry to speak across. Can you hear me? We had a power cut here in the building, and we've basically lost the feed for the last sort of 2 or 3 minutes.
So thank you, everybody. That was entertaining end to things. Please go and have a cup of coffee. There's probably the sort of backlog of chocolate, so eat some of that. And yeah, we'll clap again for good measure.